Welcome back, grade 6. Today we're working on Nelson Math, Chapter 2, Section 5, Problem Solving and Communicating. This is a problem that we are going to be solving using a little bit of logic and our place value charts right here. The operations that we do, when I say operations, I mean multiply, divide, add, and subtract, those ones you've been using for years. However, they have to be applied properly in this question for it to work. So let's read the question. The number of personal computers in use in Canada increased from about 17.2 million in the year 2000 to 22.39 million in 2004. About how many additional computers were in use each day? Explain how you solved the problem. Because the question says about, this will be an estimate. We also know it's going to be an estimate because here the numbers have been rounded to 17.2 million and 22.39 million. So those are estimates. Had they been exact numbers, we would have gotten right down to the ones value. But we don't have that. So we know for sure that this must be an estimate. So I've written the numbers down here. The 22.39 million was the year 2000. The 17.20 million is the year 2004. Actually, that's reversed. 22.39 is from 2004, and 17.20 is from the year 2000. So here are our numbers. Notice the way also I'm using the millions column here, and this 17.2 million, this 1 is not really a 1. This 1 has many different values. If we're talking about millions, it could be 10 million, but we could also be talking about ones, which would be 10 million ones, and that applies to every digit that's here. So the increase in those 4 years, because we're looking at 4 years approximately, we can find the difference between these two numbers. So if we use a calculator or the standard algorithm, we know the increase was approximately, give or take, 5.19 million. And I say approximately because we have all of these numbers rounded. How do we round it? For example, the 22.39 to 22.4, that would have also been a valid way to do this question. And our difference would have been 5.2. That's also valid. Keep in mind there are many different valid answers to this kind of a question here. As long as our thought process is shown and it all makes sense, it would be considered correct. So this is not the number per year or per day, because the question's asking how many added about per day. Well, this 5.19 million is telling us that there were 5.19 million computers added over 4 years, not in one day. So we want to find out how many were added in a day. We can start off by finding out how many were added in 1 year. I'm doing this calculation right here. So 5.19 million divided by 4 years is approximately 1.3 million added per year. And that's in 1 year. However, we also could have done it, instead of in millions, we could have done it in ones. The second line here is showing if I calculated it in ones as opposed to millions. These are the same value, they're equivalent, but they're named differently. In this number right here, 1.3 million, I'm using millions. In the bottom number, I'm using ones. So let's see where I got these numbers. This 5,190,000 comes from this 5.19. So this 5 means 5 million. And this 19, assuming we have all the zeros in here as placeholders, is 190,000. This 4 is still a 4 because it's 4 years. That has not changed. And if we did 5,190,000 divided by 4, it's approximately 1,300,000 per year. But that's per year. We want to know per day. So we're going to take this 1,300,000 or 1.3 million and divide it by 365 because there are 365 days in a year. So I've gone ahead and done 1.3 million that we would have had in 1 year and divided it by 365. But we're facing a little bit of a problem here. When you do this calculation with a calculator, your quotient, the answer to a division, comes out to 0.003561 per day. I'm going to put that right here to see if you can predict what our number would be in ones. So here's our 0 and 0, 0, 3, 5, 6, 1, and we'll copy our decimal here. There we have our decimal. So this number is rather useless to us because we don't have it in ones, 0.003561. But from this, we can see what our ones would be, which is right here. So our 1 ones, 10 ones, 100 ones, and 1,000 ones. So if we start here with 3,000, this is 5 hundreds, 6 tens, and a ones, we would end up getting 3,561 or 3,562 per day. This allows us to use our ones as opposed to millions. In this calculation, I converted the 1.3 million to ones first. So 1,300,000 divided by 365. This probably would have made more sense if we took this 1.3 million and change it to 1,300,000 so that our answer would not be in such a small decimal. It's very important to point out, however, that these two numbers are equivalent. This number here being 0.003561 million per day, and not just that's how many computers there are. So that's an important distinction to make. Thanks, everyone. Have a good day.